Hey guys, welcome back to VR Geek. So today we are going to solve a very interesting problem, that is remove nth node from the end of the list. Okay. So the problem statement here says that we have given a head of a linked list and we have to remove the nth node from the end of the list and return its head. So as a list we have like head and it's contain a value of 1 to 5. Okay. And we have given n equal to 2. So as the statement says that we have to remove the nth node from the end of the list. So the value is 2, so we have to count 1 and 2. So it means that we have to remove the 4 from here. Okay. So then if we remove this particular thing and we have to return the node again, and the value will be become like 1 2 3 5, and we have removed the 4 from there. And in this case we have only single value and n is exactly 1. So in that case, from the ending or from the beginning, if we come, it's always be 1 only. So in that case, the node or the list we are returning node only. So it is only empty only. So in that case, we just simply returning the blank. Okay, and same if the value contains only two things and we have n value n equal to 1, in that case we have to remove 2. So in that case the output will be 1 only. Okay, so let's start with the code. So first we will start with like we will create a dummy node. Okay, to handle all the edge cases like removing the first node. Okay, these things. So first we will need a list node and we'll keep the name as dummy. Okay, equal to new list node, and inside that we will keep the dummy value as 0. Fine. And after that the dummy next will be equal to the head. Okay, now we need two pointers here. One is the fast pointer and another is we will need a slow pointer. We'll make those things fast, and another we will need this node slow. Fine. Now after doing this, we have to move the pointer. Okay, like n plus 1 step ahead to maintain the gap. Okay, so for that we need a loop here. N for n I equal to 0, I is less than equal to n, till that the condition is true and we have to increment. Okay, and fast will be equal to fast dot next. Fine. After that we have to move the both pointers. Okay, until we reach to the end. So we need a while here, and we'll keep that pointer over the fast. Okay, till that it's not null. In that case, fast will be equal to fast dot next, and for the slow it will be also increment because we have to move the pointer. So it will be also look like this only. Fine. Now we have to basically do the slow is at the node just before the target node. Okay, we are reached to that area where we actually want to go. Okay, so in that case we have to do slow dot next will be equal to slow dot next dot next. So basically we have deleted that nth node, whatever the value we are giving 1 and 2. Okay, and now we have to return the dummy value. That will be our new head. Okay, that basically a updated list. Like we have, if we are seeing this example, we have removed that 4 for using this line number 24. Okay, and we have just returned the updated list. That is the output for us. Okay, so let me run this. We are getting compilation error. Okay, we have not initialized this. Okay, so we'll keep the name as dummy, and for this also we need dummy. Let me run again. Okay, it's got accepted. Let me submit this now. Fine. This is done. So the approach we have used the dummy node, okay, to simplify the edge cases. Fine. Like when example like while removing the first node, okay, in that case we use. Then we have two things. That one is the fast pointer and another is a slow. So the fast pointer move n plus one steps ahead to maintain the correct gap. Okay, and after that we have moved the both pointers, okay, in this loop. So basically it move the both pointer one step at a time until the fast pointer basically reach to the end, okay. And after that, at the line number 28, slow pointer is just before the target, so we just basically skipping by using this step, okay. We just remove that linkage, like if you see there, we just make a link between 3 and 5 directly instead of this, okay. And after that, at the end, we have just returned the dummy next. That is the our new head, that is updated one list, okay. If we talk about the time complexity here, so the time complexity is of n only because we just doing a single pass, okay, over that list. And if we talk about the space complexity, so it's only of one because we are using only pointers here, right? And the edge cases we have already covered, and we have already talked about the time complexity and space complexity and the logic, okay. So that's all for the today. Thank you for watching. Bye bye.